Okay, today we're going to learn about solving quadratic equations by factoring. And aren't you lucky? You've already studied factoring, so this ought to be pretty simple for you. Content standards, ASSE 2, and we're going to learn about some functions and using the mathematical practice, reason abstractly and quantitatively. Previously, you found the greatest common factors of sets of numbers, and now you're going to write quadratic equations in intercept form and solve quadratic equations by factoring. Two new vocabulary words this time: factored form and the FOIL method. That's not too new to you. You've been using the FOIL method for years. You can use the FOIL method to write a quadratic equation that is in factored form to standard form. The FOIL method uses the distributive property to multiply binomials. So let's look at the key concept. If you remember, FOIL stands for first, outer, inner, and last. And we have our little rainbows, like Dan likes to call it, our rainbow rule. Okay, example 1. We're going to translate sentences into equations. We're going to look at the pattern x minus p times x minus q is equal to 0. You might want to put that in your notes because that's very important. Where we're going to have 1/2 as p and -5 as q. Notice that we have a -5, so it's minus a -5. Parentheses always helps keep it straight. So x minus 5 times, or x minus 1/2 times x plus 5 equals 0 when we simplify, because we do not like having two different signs at the same time. When we use FOIL to multiply these out, we have x squared plus 9/2 x minus 5/2. So first, outer, inside, and last. We're going to multiply each side by 2 so that b and c are integers. We don't like working with fractions, so if we multiply every term by 2, we get rid of those fractions. So a quadratic equation that has the roots of 1/2 and -5, and integral coefficients is 2x squared plus 9x minus 5 equals 0. Now you can check this result by graphing the function on your graphing calculator. Let's check your progress. Let's write a quadratic equation with roots of -3/4 and 5. We're going to write it in standard form, ax squared plus bx plus c equals 0. And remember, x minus p, x minus q equals 0. Very good. Don't forget, we're not going to leave it in fractional form. We want integers, so we're going to multiply every term by 4. Zero product property. For any real numbers a and b, if a times b is equal to 0, then either a or b, or both of them, could be 0. So for example, if we've got x plus 3 times x minus 5 is equal to 0, then we can set each of those equal to 0. We did this when we were factoring, when we had the problem told us to solve. So first of all, let's factor the greatest common factor. Looking at this one, what is it we can pull out of both those terms? You're right, we can take a 3y out of both of those terms. So 9y squared divided by 3y leaves us 3y, and 3y divided by 3y is 1. So we're left with 3y times the quantity of 3y plus 1. We can set each of these equal to 0. So 3y we're going to set equal to 0, and the parentheses equal to 0. And then we're going to solve for the variable y. So we notice our roots are 0 and -1/3. How about this one? What are you going to pull out of this one? Did you say 5a? Well, awesome. You are so right. So we're going to pull out a 5a. That's going to leave us with 5a times the quantity of 5a minus 4. Set both equal to 0. And solve for the variable. Our answer, 0, 4. Time for you to check your progress. So if you'd pause the video for a moment, work the problem, come back and check to see you got your answer right. Watching your signs is very careful. You're going to end up with a -x is equal to a -3. Well, we're needing to solve for x, not -x, so you need to divide both sides by -1. So x is equal to 0 and 3. Very good. Now, trinomials and binomials that are perfect squares have special factoring rules, which that's one of the first things we learned about special products, and we've learned about perfect squares and differences of squares as well. In order to use these rules, the first and last terms need to be perfect squares, and the middle term needs to be twice the product of the square roots of the first and last terms. Now, wasn't that a mouthful? So in other words, we're looking for perfect squares, x and 3, and the middle term must be 2 times a times b, which we've done before. So we know our first term is x, second term is 3, and 6x just happens to be 2 times x times 3. So we do have a perfect square trinomial. We're going to factor it. This one's only going to have one root. Notice 3, because it's x minus 3 times x minus 3. So both of our parentheses will set up and end up equal to the same thing. So this is one of those that's only going to have one real solution. How about this one? Well, if we subtract 36 from both sides, we have a difference of 2 perfect squares. So y plus 6, y minus 6. We're going to set each one equal to 0. So our answer is going to be negative 6 and a positive 6. All right, time to check your progress. So read through this problem, solve this equation, and then come back and check your answer. Okay, if you remember when we were factoring, this positive sign means that both signs will be the same, and this middle one tells us they're going to both be a negative. So we're going to have x minus 8 squared. When we set x minus 8 equal to 0, we end up with a positive 8. Very good. Okay, factor trinomials. A special pattern is used when factoring trinomials in the form of ax squared plus bx plus c. First, we're going to multiply the values of AC. Oh, AC method. Does that sound familiar? Very good. Then we're going to find values m and p such that their product equals AC and their sum equals b. You just remember the AC method. A is 1, C is negative 15. So together they're negative 15. We're finding factors of a negative 15 that are going to add up to be a negative 2. And we found a positive 3 and a negative 5. This negative here in front of the 15 means the signs are going to be different, and the larger sign will be negative. So we're going to end up with the AC method. We're going to end up with 4 terms. Then we're going to group them, factor out what we can out of each grouping. Then we're going to set them each equal to 0. So our answer is 5 and negative 3. Okay, this one, using the AC method as well. So we've got to find factors of 5 times 24. So 120 that are going to add up to be a positive 34. So this tells us both the signs will be the same, and both of those signs will be positive. So 4 and 30. We're going to group them, factor out the greatest common factor. Now we're going to set them both equal to 0. So our answers are negative 6 and negative 4/5. Time for you to check your progress. So pause the video, solve this equation for your zeros, and then come back and check your answer. Okay, I got negative 1/2 and 4/3. So 6 times 4 is 24. I ended up using the factors a negative 8x because our middle term is negative, and a positive 3x. Very good. Okay, let's practice this one more time. You're so good at that. This one's not asking for the solution for s, it's just asking what your two factors would be. So 3s plus 1, s minus 4. Excellent. Okay, we're about done here. We're getting closer. Now, a real-world equation, solving equations by factoring. Oh, the height of the arch is given by h is equal to 9 minus x squared, where x is the horizontal distance from the center of the arch. Now, h and x are both measured in feet. How wide is the arch at ground level? So first of all, we need to know what we're looking for. We're going to find the width of the arch at ground level and find the distance between the two zeros. Well, we're given 9 minus x squared. Let's multiply both sides by -1. Notice it will not affect the 0. But now it's in a format where we can factor x squared minus 9. It's a difference of squares, so we know that it's x plus 3, x minus 3. So how far is it from a 3 to a -3? Well, simply 3 minus the -3 is 6 feet. Or if you think of the number line, -3 is 3 to the left of the 0, positive 3 is right, 3 right of the 0, so that's a difference of 6 units. Since these units are in feet, 6 feet. Now we can go back and check our answer by putting in the 3 and the -3 to see if our statement is true. Does 0 equal 0? By golly, every time it does, so both of those are good answers. Here's another problem, very, very similar to the one we just worked, so check your progress and then come back and check your answer. Well, I've got an h equals 49 minus x squared. Again, we're going to multiply both sides by -1. So we've got x squared minus 49 equals 0. Our factors are x plus 7, x minus 7, and the difference between a positive 7 and a -7 is 14 feet. Awesome. You're ready to begin the assignment. Good job, folks.